In this video, we are going to create an electrifying lightning effect using Unreal Engine's Niagara system. I am using the third-person template where we can electrocute our character to death at the press of a button. In the third-person blueprint, I have added a simple setup to play an animation montage when I press the electrocute key. To create a montage, simply right-click on your animation and choose Create Animation Montage, which gives us a montage like this. And this is where we'll add our Niagara effect so that it triggers automatically when the montage plays. That's the scene setup. Let's move on to creating the Niagara effect. Right-click in the content browser and create a new Niagara system. I choose this minimal template. Name it NS Electrocute. Open it. Here for the first emitter, you have to follow me blindly because the results won't be visible until we reach a certain point. Let's rename the first emitter to Lightning 1. Since we want lightning to spawn from the player's mesh surface, click the plus icon and search for Sample Skeletal Mesh module. Set this to attach parent. That way it uses the mesh it's attached to as the sampling source. And for the preview and default, choose Queen Mesh. In fact, convert this to a parameter by clicking the arrow Make Read from New User Parameter. This acts like a variable in blueprints. Here in the sampling setting, I change it to surface and set the random evolution to every frame. This sets up our start points. To connect the lightning to another point on the surface, we need a copy of this. So copy it and paste. You don't need to change anything in the duplicate. What we need from these two modules are the parameters they write. So if I enable this, you can see it writes the sample position into a parameter. Same in the first one. We can use these two position parameters as our start and end points of the lightning. To make a lightning, first we need particles. So I add a spawn burst instantaneous module. Set the burst to 10. Next, add a beam emitter setup module. In particle spawn, add spawn beam module. To make the beam visible, I add a ribbon renderer module. Hide the sprite renderer and you can see we have our one beam. Enable the sprite renderer for now. I move the beam emitter setup above this module. Now let's adjust the start and end points of the beam. For the beam start, it is already linked to the simulation point, but click the arrow and link it to the first sample skeletal mesh position. Then I enable this absolute beam end and link the second sample skeletal mesh position to the end position. Now when I play, you can see it randomly picks two places from the skeletal mesh each loop and make a beam between those points. And this spawn count is like the resolution of those beams. If you reduce the sprite size, you will clearly see particles forming the beam path. But to make the lightning effect from these, we need more of these beams in a quick succession that rapidly spawn and get destroyed. So for that, here in the emitter state, I set this to self and set the loop duration to 0.1. Then in the initialize particle settings, I set the lifetime to 0.25. Now this emitter runs every 0.1 seconds and the lightning will last up to 0.25 seconds. Then in the spawn burst module, change this to random range int and set it to 10 and 50. This will help us to get different looking distortions later. I don't want to see the particles anymore, so disable the sprite renderer module. I add a beam width module. We can use this to change the beam width. Back in the initialize settings, I set the color to direct set and give it a bluish tone. To make it glow, increase this value to something like 100. Let's add this to the montage to see it with the animation. I open up the montage. Now, if you want to just trigger the particle effect, you can right click, add notify and use play Niagara particle effect. But I like to trigger and then destroy after some time. For that, we can use notify state time Niagara effect. It gives us 2 points to set as start and end points of the effect. Here in the details, I select the Niagara effect we created. This is something you must remember. Whether you want it or not, you must assign a socket for the effect to work. So here in the socket name, I attach this to the root bone. Save it and go to the beginning of the animation and hit play. You'll see the lightning effect trigger. Because the character is shaking, it may not perfectly stick to the mesh, but that won't be noticeable once we add distortion. Let's see how this works in the game. We got the basic effect. Let's polish it. Back in Niagara, in beam width, change it to float from curve. For curve index, use ribbon link order. This gives us the option to change the width of the beam or ribbon along its path. I change the curve to this and adjust the handles like this to give the beam some taper at the ends. I don't want the ends of the beam to be completely pointy, so here I add 0.2 to give it some thickness at the end. If you want to make the lightnings thicker or slimmer while keeping this flow, you can use this scale curve option. I'll set it back to 1. To add distortion to the lightnings, in the particle update, add Jitter Position module. As the name suggests, it's going to add some noise to the particle's position. You can see the immediate effect in the preview. To adjust the jitter amount, you can increase or decrease this value, but once again, I change this to float from curve. Change this into ribbon link order. Shape the curve to have strong distortion in the middle and none at the end. Use scale curve to fine-tune the intensity. But I want to increase the distortion over time, so change this to float from curve and select this template. I keep it at normalized edge. Now the distortion increases as the lightning ages. Use this scale curve to increase or decrease the overall strength. Currently, distortion is very smooth. In the ribbon renderer, to reduce smoothness, I can either set the tessellation to custom and adjust these values, or completely disable it, which is what I prefer. Right now, lightning spawn in this straight line. Let's add a bit of curvature to it using another parameter that our Sample Skeletal Mesh module writes. You can see here that it writes this sampled normal parameter. This is what we are going to use. In the beam emitter setup, I enable use beam tangent, and we get this curved lightning with that. To control it, I enable this absolute beam tangent and link our two parameters to the start and end tangents. Actually, you need to keep this disabled. Sorry for that. Now you can see we have a nice curvature to the lightning, but we have no way of increasing or decreasing the curvature. So change this beam start tangent to multiply vector by float. And for this vector, I'll link the skeletal mesh normal parameter. And do the same for the end tangent and select the second skeletal mesh normal parameter. Now we can use this float value to adjust the curvature. In fact, you can change the float to a random range and add some randomness to it as well. And that is our basic electrocuting effect using Niagara. To make it 10 times better, here I add a new renderer, this time a light renderer. This will cast light on the nearby surfaces from our lightning. Isn't that cool? Let's add a second layer of this. I hit Ctrl D to duplicate the emitter. For this one, increase the spawn count to 25 and 40. Reduce the beam width and the distortion strength. By default, Unreal uses this material for ribbon rendering. It kind of fades off towards the end of the lightning. I don't want that. So let's make a new material to use for our lightning. I right click and create a new material. Call it m_lightning. Double click to open it. Select this big node and change its shading to unlit and enable two-sided. Then to use this with our Niagara system, we can add a particle color node. Plug this RGB into emission color. Save it, and that's it. Assign that material to the lightning emitters. Now I want to make some particles bursting out effect. Add another emitter, minimal one. Call it sparks. In emitter state, set it to self, loop duration 2.1, same as the others. Then search for other and add spawn particles from other emitter module. Click fix issues. It will add another module here. Click fix issues again. I want to spawn particles from our first lightning emitter, so here type that emitter name and select it. You can see immediately we are getting a lot of particles. In initialize settings, change the size to uniform and set it to 5. You can play with these two values to increase or decrease the spawning amount. Then here I add velocity module. I want them to burst outwards, so set the mode to point. Now it bursts outwards from the simulation point, which is around the root bone of the skeletal mesh. I give it 100 unit offset on Z to make it burst from character center. Set the speed to 100. Change the lifetime to random 0.8 and 1.5. Then add a gravity force module. I set this to direct set and choose the color from earlier. Change the sprite size to random uniform 0.2 and 0.5. We have the bursting particles. Let's add a collision module. Set the bounce to 0.2 and friction to 0.1 to make the particles slide more. To make the particles fade over time, I add a scale color module and change the alpha to a curve. I keep the default curve. Then, just like before, I add a light renderer. This time I enable alpha scales brightness. It will take the particle's alpha value to decrease the brightness over time. It looks awesome, doesn't it? Let's make it even better with some smoke. For that, I want an asset from Unreal Starter Content. In the content browser, go to Add Feature or Content Pack, Starter Content, and add it to the project. I want to use a material inside this particles folder. This 𝒚𝒐𝒖𝒓 one. It's an 8x8 sprite sheet texture. Back in Niagara, right click and add a fountain emitter. I keep the emitter state settings as it is and change the spawn rate to 25. In initialize settings, I set the color, but this time introduce some alpha and reduce the value to 0.7 to make it darker. Increase the min and max sprite size to 20 and 40. Keep the rotation at random. I delete the sphere location module. I want to spawn the particles from the character mesh. For that, we can use the skeletal mesh location module. For the skeletal mesh, I drag and drop the parameter we made earlier. Change the mesh sampling to surface triangles. I change the velocity to linear. Disable the gravity and drag. Set the velocity to random range vector. I changed the set value to 40 and 70 to make the particles slowly rise up. For the scale color, I use this template. In the sprite renderer settings, I select the material we imported from the starter content. It's called 𝒚𝒐𝒎𝒆𝒏𝒕. So here in the sub UV settings, I set the blending to true and set the sprite sheet size 8x8. I dismiss this. To make the sprite blend over time, we need to add a sub UV animation module. Select the sprite renderer from here. Everything else is fine. I want to scale the smoke size over time, so add scale sprite size module. At the beginning, I want it to be the default size we set in the initialize settings, so set the key value to 1. Then at the end, set the second key value to 2, so it will double the size towards the end. To add some rotation over time, add a sprite rotation rate module. Set the rate to 20. If you want, you can set it to a random range float and make it rotate at different speeds. I set it to -20 and 20. And we have smoke rising from our character. But I want the smoke to last longer than the lightning. Right now, everything inside our Niagara system deactivates once this state ends. I want the lightning to last from here to all the way here. That is about 6.5 seconds. Let's remember that and increase the notify state to make the smoke last longer. Back in system, in the first lightning emitter, I set the behavior to multiple. If our loop duration is 0.1, then to last this for 6.5 seconds, we need to loop this emitter 65 times. I do the same in our other lightning emitter. Since the sparks inherit from the first emitter, we don't need to worry about that. That's how you electrocute your character in UE5 using Niagara. If you'd like to see a version where lightning spawns from the character and hits nearby surfaces, let me know in the comments. As always, you can grab the project files from my Patreon page. Don't forget to like, subscribe and hit that bell icon. Until next time, see you later.